When you are building responsive content in Flex, positioning determines how objects behave as the screen size changes. That might sound like a small setup choice, but it affects almost everything your viewer sees, whether objects stay aligned, whether content overlaps, whether navigation stays visible, and whether a section scrolls as you expect. In this video, we will look at the 4 position types in Flex: absolute, stack, fixed, and sticky to parent. We will compare what each one does, when you would use each position type, and a few common issues to watch for as you build. Before we compare the position types, it helps to start with the hierarchy structure Flex uses. In Flex, every object is positioned in relation to its parent container. The hierarchy is canvas, section, group, individual asset. So, if an image is inside a group, the group is the image's parent container. If that image is not inside a group, but it is inside a section, then the section is the parent container. And if the image is not nested within a group or section, the canvas serves as the parent container. That parent relationship matters because alignment, spacing, and position are all calculated relative to the container the object lives in. For example, if I left align a text box within a group, Flex aligns it to the group's left edge, not the left edge of the entire canvas. That is different from how many studio users are used to thinking about alignment, so it is worth keeping in mind as we move through each position type. Let's start with absolute positioning. Absolute positioning lets an object sit freely anywhere inside its parent container. An absolute object does not push sibling objects out of the way, and sibling objects do not push the absolute object out of the way. That makes absolute positioning a good fit for when you want precise visual placement, especially for decorative images, layered visuals, or objects that intentionally overlap. For example, let's say you have a hero section with a headline, a product screenshot, and a decorative shape behind the screenshot. The decorative shape is a good candidate for absolute positioning because you probably want to place it exactly where it looks best and may want it to overlap other objects. The easiest way to think about absolute positioning is that Flex lets you place the object exactly where you want it. But Flex will not automatically move nearby objects out of the way, so an absolute object can cover other content when the screen gets smaller or when its parent container changes size. To prevent that, use constraints intentionally. In the inspector panel, constraints let you anchor an absolute object to reference points on the parent container. You can use fixed pixel values or relative percentage values. So instead of just placing an object visually and hoping the object stays in the right spot, you can tell Flex how far that object should sit from the left, right, top, bottom, or center of its parent container. A common pitfall with absolute positioning is using it for content that should flow with the page. For example, if you use absolute positioning for a row of cards that should stack on mobile, those cards may overlap or drift out of alignment as the canvas changes. If the content needs to line up with sibling objects and reflow as the space changes, stack is usually the better choice. Stack positioning lines objects up with their siblings inside the parent container. Stacked objects cannot overlap, and their positioning is determined by the parent container's layout settings. That makes stack positioning one of the most important tools for responsive layouts in Flex. When objects are stacked, Flex can manage spacing, direction, wrapping, padding, and alignment for the group. You are no longer placing every object manually. Instead, you are defining a layout system for the parent container. For example, let's say you are building a products section with several tiles. If the tiles should sit in a row on desktop, but wrap or restack as the available space changes, stack is a strong fit. You can set the parent container's stack direction, add a gap between cards, and decide whether the cards should wrap when there is insufficient horizontal space. Stack is also useful for content that needs to stay organized in a predictable reading order, such as navigation links, resource cards, testimonial blocks, or sections on a landing page. The common pitfall with stack is expecting a stacked object to behave like a freely placed object. Once an object is stacked, the parent container controls the object's position. So if you try to drag one card slightly over another card, stack will not allow that overlap. That is the point of stack. Stack protects the layout from collision. Another issue to watch for is the parent container's layout settings. If the gap, padding, direction, wrap, or clip content settings are not configured correctly, the stacked objects may not reflow the way you expect. The prevention step is simple. When a stacked object looks wrong, inspect the parent container first. The child object may be fine. The layout setting that controls the child object probably lives on the parent. Next, let's look at fixed positioning. Fixed positioning pins an object to the screen viewport. That means the object stays in the same on-screen location as the viewer scrolls the page. Some common use cases would be a persistent navigation bar, a floating call to action button, or an element that should remain visible while the viewer moves through the experience. Fixed positioning is different from absolute positioning because absolute positioning relates to the parent container, while fixed positioning relates to the viewer's screen viewport. So, if I place a button at the bottom right corner using fixed positioning, that button stays in the bottom right corner of the viewport as the viewer scrolls. Fixed objects can also overlap other content because they do not stack with their sibling objects. That overlap can be useful, but it can also create problems. The most common pitfall with fixed positioning is covering important content on smaller screens. For example, a fixed button that looks great on desktop may cover body text or another button on mobile. To prevent that, check the fixed object across responsive variants and use breakpoint overrides when the fixed object needs different placement on different screen sizes. Another important limitation is that only direct child objects of the canvas can be set to fixed, and sections cannot be set to fixed because they are always stacked. So, if fixed is not available for an object, check where that object lives in the content hierarchy. The object may be nested within a section or a group, meaning it is not a direct child of the canvas. Now let's compare fixed positioning to sticky to parent positioning. Sticky to parent positioning pins an object within its parent container as the viewer scrolls through it. So fixed relates to the viewport, sticky to parent relates to the parent container. That difference is the easiest way to decide which one you need. Use fixed when an object should stay visible as the viewer scrolls the whole page. Use sticky to parent when an object should stay visible only while the viewer is inside a specific section or container. For example, let's say you have a product page with a long feature section. You might use sticky positioning for an in-section menu that filters categories, like the example we see here. Once the viewer scrolls past the parent container, the sticky object scrolls away with the rest of that container. That makes sticky useful for section-specific guidance, side notes, visual anchors, and long content blocks where the viewer benefits from a persistent reference. The main pitfall with sticky positioning is expecting sticky to behave like fixed. Sticky is bound to the parent container, so the parent container's size and placement determine how long the sticky object remains active. Another pitfall is expecting sticky to pin horizontally. Sticky objects stack within the parent container along with stacked position siblings, and sticky positioning pins to the top or bottom of the parent container. So if an object needs to stay pinned to the left or right edge of the screen, fixed may be a better option. Here is a simple way to choose between the four position types. Use absolute when you need precise placement inside a parent container, especially for layered or decorative objects. Use stack when objects should line up, keep spacing, avoid overlap, and reflow with the layout. Use fixed when an object should stay pinned to the viewer's screen as the viewer scrolls the page. Use sticky when an object should stay pinned only while the viewer scrolls through a specific parent container. So, in summary, positioning in Flex is all about relationships. If your responsive layout is not behaving the way you expect, start by checking two things: the object's position type and the object's parent container. Most positioning issues stem from a mismatch between what the object is supposed to do and the container or position type that controls it. Once those relationships are clear, it becomes much easier to build Flex experiences that resize, restack, and scroll the way you intended.